Hello friends, welcome to my channel Economica. I Dr. Gopal B. Saraswat welcome you all to my channel. Today for topic for discussion is hypothesis testing using statistical methods. And especially here we are going to discuss which statistics test to apply and when. क्योंकि अधिकतर जो researchers हैं, students हैं, they generally come across a situation when they are having a different variables but they don't know which statistical test to apply and in what circumstances a particular test has to be there. So here we are going to discuss what are the different challenges, what are the different test statistics, which test to apply in what condition. So these all questions will be answered in this video. So let's start the video. We have bar chart in statistics which is being used for a different purpose. We have a normal distribution curve, we have a histogram, we have a line chart, and we have a scatter diagram. But question remain the same, which one to use for my data? So which graph will be helpful in visualizing my data, the characteristics of my data? That question remain unanswered. Further, next question we generally come across with is which test to use. In such scenario, we generally come across a test called student t distribution test, z test, ANOVA, chi-square, f test, Mann Whitney U test, sign test, and regression analysis. So we are here and coming across with the different tests of statistics. All those tests have a different characteristics and can be applied in a particular situation. For example, regression analysis. Regression analysis can be used for finding a relationship between the variables. But when we move to the regression analysis, we also come across a same question, which regression to apply, because we have a different types of regression, linear regression to logistic regression, and which one is suitable for my test statistics for finding out the relationship. This question again comes to my mind. So one more thing when we move further is parametric test and non-parametric test. So this indicates that we have a lot of questions to answer. We started with which chart to plot, which statistics to apply, which regression will be useful for my test statistics to find a relationship. Either should I go for parametric or non-parametric test? So a lot of these questions we generally come across while starting our data analysis in the research. So the answer is measurement scale. The first thing you must identify is measurement scale of your variables. We have three types of measurement scale: nominal, ordinal, and interval and ratio. The nominal scale is a scale which means our data is binary. For example, we may have a registration number or roll number of students, gender of student male and female, ethnicity of the peoples, caste of the person, place where person born. These are the different variables we generally come across, and these are the nominal scale variables. Second is the ordinal scale variable like rank and the response magnitude. Response magnitude means we have a range of answers to a particular question. For example, in ordinal data, we have chilies may be hot, hotter, or hottest. So here we are trying to identify the magnitude of the response. Similarly, we may have a question and we have a different answer on the based upon the Likert scale, where we have a strongly agree, neutral, disagree, and a strongly agree. So strongly agree to strongly disagree, this range of options as answers are available before the respondents. So this is again a type of the ordinal data or the categorical data. The third one is the interval and ratio scale, where we generally come across with the number of students, number of people, number of respondents. Another type is the height of a person, weight of the person, temperature. These all are the examples of interval and ratio scale. So once we identify which is the type of my variable in terms of measurement scale, whether I am dealing with ordinal data, nominal data, or interval and ratio scale, the first thing to identify is these three scale from my data. Once you identify that, you also identify which one is independent variable and which one is dependent variable. If my dependent variable is a scale, means the interval and ratio scale variable, and my independent variables are nominal and ordinal, including interval and ratio scale. So in such scenario, my statistics test will differ from one relationship to another. Further, we also emphasize upon the normality. This is the normal curve. If my data is fitting in the normal curve and data is normally distributed, the test statistics I may apply is different. If my data are non-normal, not normally distributed, then I have to go for a different test. So in case of normal data, I must use parametric test. If my data is non-normal, then I have to use non-parametric test. So in later part of this video, we are going to discuss what are the parametric tests and what are the non-parametric tests. But here one thing is clear, if my data is normally distributed, I will apply parametric test. If my data is non-normally distributed or non-normal, then I will use non-parametric test. So the first classification is on the basis of measurement scale of my variable, ordinal, nominal, and interval and ratio. And second is on the basis of normal distribution of data or non-normal distribution of data, on the basis of which I will decide to use a parametric or non-parametric test. For example, the basic thing the first hand information we try to collect from the data is summary statistics. So in summary statistics, the first thing we generally come across is the average of my variable or my data. But this average calculation is purely based upon the measurement scale of your data. If your data is nominal, then your data can also be ordinal scale. So if your data is nominal, you have to use mode as the average of your data. If you want to calculate the average or the mean, so mean could not be a suitable thing to calculate in case you are dealing with only nominal data. The best thing to calculate is mode. If your data is ordinal, then you have to calculate median or interquartile range. You should not calculate either mean in both the condition if you are dealing with nominal data or ordinal data. In case of nominal data, only mode you have to calculate. In case of ordinal data, you have to calculate median or interquartile range. But if you are dealing with the scale variable, we call it like ratio, interval and ratio scale variables, then if your data is normally distributed, or you can say the parametric, then you must calculate mean and standard deviation for finding out the average and spread. And you can also calculate median or interquartile range if your data is not normally distributed. So here the first hand information that you want to bring out of your data as a characteristic is purely based upon the measurement scale of your data points. In case of nominal, mode. In case of ordinal, median and interquartile range. In case of normally distributed but the data is scaled, then mean and standard deviation, otherwise median and interquartile range. Further, which graph to plot? That was another question we generally come across with. So here you can see in my left hand side the variable measurement scale. This means that what is the type of measurement scale of a variable. If your variable is one categorical variable, or you can say the ordinal variable. Two categorical means if you have a two categories or two ordinal data points are having a more than two categories. If your data is scaled variable, where one scale is there, two scale means the more than one is there. If your data is combination of two, ratio or interval scale as well as the ordinal data. If your data is scaled by time, and finally if you are dealing with one scale variable and another categorical variable. On the basis of these measurement, you decide which chart to plot, which figure to plot. It also includes the purpose and the summary statistics you may apply. Let's see this. If you are dealing with one categorical variable, you must show the frequency of a data, percentage or proportion. This is the purpose you can come across with. The chart you can use in case of categorical, or you can say the nominal and ordinal data, is the pie chart and the bar chart. You should not use histogram in the one categorical variable. That is sure. The summary statistic that you can calculate is the percentage. That is the only thing that you can calculate here. Second thing, if your data is two categorical data, then you should use multiple bar or stacked bar as a chart type. If two ordinal or two nominal data points are there or variables are there. Here you are trying to compare the proportion within the groups. This is the purpose. And for that you can use percentage within the groups as a summary statistics. If you are dealing with scaled variable, ratio and interval variable, then if your purpose is to show the distribution of results, then you should use histogram. And as a summary statistics, you can use mean and standard deviation. If you have a two scale, means the two ratio scale variables, then you can use scatter graph to show the relationship as well as to find out the outliers in the data points. And the summary statistics you can use here is correlation coefficient. Further, if you are having a variable like one scale variable and one categorical, or you can say ordinal variable, and your purpose is to compare the spread of values, then you should use box plot as a chart. And for summary statistics, you can use median and interquartile range. If you want to show your data as a scale of time, and this is the data which is in ratio form or a time series form, then you can use a line chart where you could show the two time comparison of the two different variables. Here mean by the time can be used for a summary statistics. Further, if your data is one ratio scale variable and two categorical variable, two nominal or ordinal variables, then means plot should be plotted. The purpose is to provide a combined effect of two categorical variable on the mean of the one scale variable, and here the summary statistics you can apply is mean. So this is the different graphs you can plot on the basis of the type of variable. Further, to find the appropriate statistical test based upon the dependent variable under the measurement scale. So here you can see first column is for dependent, or you can say outcome variable, and second column belongs to independent or explanatory variable. If your dependent variable is in scale form, as you can see here, ratio, ratio, ratio and ratio. So if in the first condition, if your dependent variable is ratio scale variable and your independent variable is nominal scale variable. So then the purpose is to compare the independent groups, then you should use independent t-test if your data is normally distributed. If your data is not normally distributed, then you should use non-parametric test, which is the substitute of t-test. We call it Mann-Whitney test or Wilson rank sum test. Further, if your dependent variable is ratio scale variable and your independent is nominal scale variable, and you have a groups 3 or more than 3, then you may use one-way ANOVA if your data is normally distributed, and if your data is not normally distributed, then you may use Kruskal-Wallis test. Further, if your data is or your dependent variable is scale variable, ratio scale variable, and you have a independent variable which is based on time or condition variable, where your purpose is to compare to find the average difference between the paired, for example, weight before experiment, weight after a experiment. So you should use pair t-test if your data is normally distributed, otherwise Wilson sign rank test. And finally, if your data or especially the dependent variable is in ratio scale and your independent variable is in time and condition, and you are dealing with 3 and more than 3 measurement scale variable, where you are trying to find out the repeatedly you conducting a particular test and you are trying to compare the result of these tests, then you should use repeated measure ANOVA in case of data is normally distributed. Otherwise you may use Friedman test. So this is for the comparison of groups you may use. In case of association, if you want to test the association, so in the same manner, if your dependent variable is in ratio scale and independent also in ratio scale, and you are dealing with two variables, so you may use Pearson correlation coefficient. If data is non-parametric, then you may use Spearman correlation coefficient. Further, if your data dependent variable is in ratio scale and independent is in any scale, in any measurement, nominal, ordinal or ratio or interval, then the purpose is to predict. So you may use simple linear regression. But if your dependent variable is nominal scale or categorical variable and your independent variables are either nominal, ordinal, ratio and interval, in such scenario, I am again emphasizing on this point, if your dependent is nominal and your independent values are any measurement scale variable, then you should use or you must use rather logistics regression. This is the clear differentiation between the simple linear regression and the logistic regression. In simple linear regression, dependent variable is in ratio scale and others are any form of measurement scale variable. But in case of logistic regression, your dependent variable is nominal, but other variables, the independent variables, are in any scale. And finally, if your dependent variable is in categorical variable, your independent is also a categorical variable, then you should use non-parametric test, which is chi-square test. So this is test of association. So you are able to know now what are the tests for comparing two groups, two or more than two groups, and what are the tests for test of association or to find a relationship. Now next question is regression versus ANOVA. When to use regression and when to use ANOVA. When we have a dependent variable as a ratio scale variable, but my first independent variable is ratio and second independent variable is either ratio or nominal, then I should use multiple regression. If my dependent variable is ratio and first independent variable is nominal, independent groups, second independent variable is also nominal, then I should use two-way ANOVA. If my dependent variable is ratio scale independent variable is first one is nominal and second is again nominal but repeated measures, then I should use two-way ANOVA with repeated measures. If my dependent variable is ratio, independent is in nominal independent group and second is nominal repeated measures, then I should use mixed ANOVA. And finally, if the ratio is my dependent variable measurement scale, independent first variable is in nominal, second is in ratio, then I should use ANCOVA. So you can see here from the first to last, in the first where we were using multiple regression, my independent first variable is in ratio and second is in either ratio or nominal. But in case of last ANCOVA, my having independent variable is nominal, first is independent variable nominal and second is in ratio scale. So once the independent variable interchanges, you have to identify a suitable test for your test statistics. Further, this is prescribed that use of regression if you have only scale or binary independent variables. Categorical variables can be recoded to dummy variables, but if there are a lot of categories, ANOVA is preferable. For example, if my dependent variables having a lot of categories, and this is the categorical variable as a dependent variable, if I am not able to convert it into the binary form 0 or 1 form by coding, then I prescribe to use ANOVA only as a test statistic. Final question we are dealing with here is parametric versus non-parametric test. Here list of parametric and their substitute in non-parametric test is available. In parametric test you may use independent t-test, but in case of non-parametric you may use Mann-Whitney test or Wilson-Rankine test. The one-way ANOVA in case of parametric and Kruskal-Wallis test in case of non-parametric. Pair t-test in case of parametric and Wilson-Rankine test in case of non-parametric. Repeated measure ANOVA in case of parametric and Friedman test in case of non-parametric. Pearson correlation in case of non-parametric and Spearman correlation coefficient in case of non-parametric. But in case of simple linear regression, logistic regression, you may use here in parametric, and here in case of non-parametric you may use chi-square test. So this is how the parametric tests are different from non-parametric, and here the basic difference between these two is the normality of data. If my data is normally distributed, I should use parametric test, otherwise I should use non-parametric test. Further, to make a decision or to arrive on decision, we should follow this particular decision making table. Let's see this. Choosing a statistical test. First of all, you have to make a decision. Predictor variable or categorical or quantitative. What is this predictor variable? The variable on the basis of which you are predicting the dependent variable. Okay. So predictor variable to which you are predicting. Here in my case, we generally have two types of variable, independent and dependent. If my independent variable, predictor here means independent variable. If my independent variables are quantitative, then what I should do? I should go for identifying what is the outcome variable. Independent variable is quantitative, okay, that is good. What is the dependent variable nature? Is it categorical or quantitative? If the dependent variable is categorical, I should go for logistic regression. This means that independent variables are trying to predict the categorical variable which is dependent variable, and I should use logistic regression. But if my dependent variable is a quantitative variable or ratio scale variable, then I should again ask myself how many predictor variables, how many independent variables I am having. One, then I should go for simple regression. If more than one, I should go for multiple regression. So this is the decision making I should do in such scenario. Further, if I move in the leftward, if my independent variable is in categorical, maybe nominal ordinal variable, and if my dependent variable is in categorical variable, I should go for non-parametric test. My independent is categorical, my dependent is categorical, I should go for non-parametric test. But if my dependent variable is in ratio scale or quantitative, I should go for comparing means test. In that, I should identify how many groups are there I need to compare. If there are only two groups, I should go for t-test. Otherwise, I should go for more than two based variable test. If my groups are only one, I may use one-way ANOVA. More than one, I may use MANOVA or two-way ANOVA. This is what I should do. So on the basis of this table, you can make a decision which statistical test to apply in your research or in your data analysis. I hope you like my video. Thank you for watching.